Hello and welcome to Algebra. My name is Mr. Stewart, spelled S-T-E-W-A-R-T. I am a teacher at Penfield High School. Hopefully you guys are all staying healthy and doing all right, and I'm going to get started right off the bat. If you have access to a calculator, then you should have that out because some of the work we're going to do today will require a calculator. You can do it without a calculator, but all of our lives are made easier with technology, which is why we can do this lesson the way we are doing it right now. If at any time you need to reach me, just like some of the emails that I have sent you, I can be reached at kstewart@penfield.edu. Now the notes that we take, you can find the copy of the Word document on the Schoology account that you created with the access code that I gave you. You can also just take the notes on plain paper if you can't have, or if you don't have access to a printer or can't print out the documents from Schoology. You can just do all the work on your own regular paper, and that works fine as well. You can pause the video anytime you need if I'm going too fast, and you can stop and rewind it anytime you need if you want to see something again. All right, so here we go. We're just going to talk about classification of numbers to start with and PEMDAS. Do you guys remember? Please excuse my dear Aunt Sally. It's just a way for you to remember how to do the order of operations, because every mathematics problem, no matter where you go in the world, is solved in the same order, which is why some people consider mathematics the universal language. But in order to do algebra, we need to have some basic understanding of numbers. So let's start off with the classification of numbers. There are different sets and different groupings of numbers. The diagram at the bottom of this first page is a visual of how some sets of numbers fit inside of other sets. So the biggest set of numbers that we see here is this real numbers. Okay, that has a bunch of different subgroups inside of it. So I'm going to start with the smallest one, the whole numbers here. I'm going to start with that one and then work my way up. So the whole numbers are the counting numbers and 0. Now when you count using 1, 2, 3. You don't use decimals or fractions. Sometimes we do if we're joking around, but if you want to count how many pieces of pizza you had for dinner, you would start with 1, 2, and 3. But the whole numbers, if you imagine the 0 looking like the picture of a hole on a piece of paper, like if you were to draw a hole on a tree, usually make a circle on the tree and color it in dark. So the whole numbers start with 0 and just use regular numbers that you would count with, 1, 2, 3, 4, 5, and it goes on forever. So to show a set of numbers, we use set brackets. That's these squiggly things. Okay, and we put the list of numbers on the inside. Now let me show you a trick of how to draw nice, neat, squiggly set brackets. What you're going to do is use the alphabet. So you'll start with the letter S, and from where the S ends, you can write a letter Z. And you put those together, and you have one smooth set bracket. When you close it, on the other end, you do the Z on top and the S on the bottom, and when you put them together, you got one smooth, nice looking set bracket. So that's how you can practice your set brackets, S and Z, and then Z and S. Okay, in algebra, most of what we do, or about half of what we do, will focus on using integers. If you look at our diagram down here, the whole numbers, which is 0, 1, 2, 3, so on and so forth, those numbers then can be added to by making everything that's positive also negative, and that's where we get our list of integers. So the integers are the positive version of the whole numbers, so it starts off with the same things, but it also includes the negative So it's positive and negative whole numbers. So when we write it, we use our set brackets. Let me do that again. We do a letter S, then the letter Z to start our set brackets. And it comes from negative infinity. There is no smallest integer. We can keep going down the same way that our whole numbers continue to go up. So when we get close to 0, -3, -2, -1, it's like temperatures rising. And then from 0 it goes 1, 2, 3. So we have the positives and negative whole numbers. And then we close our set by doing a Z on top and a letter S on the bottom. So the whole numbers are all positives, and then 0. 0 is considered a neutral number. It's not positive nor negative. It's neutral. And the integers are the positive and negative versions of the whole numbers. Still no decimals or fractions. Decimals or fractions are when we get into the rational numbers. So if I take all the positives and negatives, so now we have -3, -2, -1, 0, 1, 2, 3. Now when we get into the rational numbers, this is where we pull in decimals and fractions. When you add and subtract integers to each other, your answer is another integer. But when you start using division with integers, that's when we start getting decimals and fractions. Now to list every single possible decimal and fraction would be impossible. It wouldn't work. We wouldn't have room, and we don't want to take the time. So we're basically going to write this in words. Any number written as a fraction a over b, where a and b are integers. And then when you divide it, it would give you a decimal. Now, let me give you something else. What you're going to need to remember most is that rational numbers repeat and or end. Rationals repeat. They both begin with the letter R. So hopefully that's a little trick that you can use to remember. Rational numbers repeat. Rational numbers repeat. Rational numbers repeat. Rational repeat. Rational repeat. If I repeat it enough, you remember that rational numbers repeat. The next list in our diagrams over here on the side, irrational. The prefix ir means not. So these are not rational numbers. If rational numbers repeat, then irrational numbers never repeat. Never repeat, never end. They do both. They don't repeat and don't end. So you may have heard your teacher in the past say a non-ending, non-repeating decimal. Never ends, never repeats. All of these groups that we have already just talked about is in the one big giant category of real numbers. So the real numbers would be all sets above combined. And that's really what algebra focuses on, all real numbers. As you move on in the math, you may get into imaginary or complex numbers. Imaginary numbers or complex numbers, those are simply the square root of a negative number. Square root of negative numbers. So the square root box of a negative value. That's imaginary. And we'll see that a little bit this summer, but not much. Most of our focus will be on rational, irrational, and integers. So let's get into it. What you're going to have to do is explain the difference between rational and irrational. And it's pretty simple. you either have a number that ends or rational repeats, and if it never ends and never repeats, it's irrational. Now, some clues about how to see if it never ends or never repeats, because sometimes you can't tell just looking at the calculator. What you're looking at or looking for is a square root of a number that's positive. That's the easiest way to recognize an irrational number. Or anything with the symbol pi is also irrational. Those are the two easiest ways to spot an irrational number. Calculator time. So what we're going to do is practice the order of operations. But because we have technology, we can just put all these different expressions into the calculator all at once and let the calculator do the work for us and get to the answer. Technically, when we look at PEMDAS, we look inside the parentheses first, and inside the parentheses it's just a regular -8, nothing that we have to do with that. Next we look for exponents, there are no exponents. Next we multiply. So that means that I would do the 6 times the -8, making it -48. The plus sign gets carried down, and then the 6 times -8 makes it -48. Now, mathematically, adding a negative is exactly where mathematicians came up with subtractions, because they didn't want to write two symbols if they added a negative, so we dropped the plus and just made it 48, -48, 4 minus 48. In your calculator, you can do 4 minus 48, get the answer. According to PEMDAS, we did the multiplication. There is no division. Now we add or subtract left to right. So I do 4 minus 48, which is -44. So what New York State wants you to do is to be able to explain whether this answer is rational or irrational. And this answer is rational because the answer ends. You could also say it technically it repeats, because it would be 44.000 going on forever. But if you remember what I told you on the previous page, there's no square roots here. And the easiest way to identify an irrational number is looking at the possibility of the existence of a square root. We don't have that, so our answer is going to be rational. So, on to the next question. You can go to your calculator and type it in, or we do PEMDAS, parentheses first. So, in my fraction, what I would do first is the parentheses of 3 minus 2. Keeping the 4, keeping the parentheses, keeping the division, and keeping the denominator as a 3 plus 9. So inside the parentheses is now just a 1. There are no exponents. Next thing is to multiply. 4 times 1 is 4. Now this is where things can get a little bit tricky, and this is why using the calculator makes it so much easier. Should we divide or add the 3 and the 9 together? Because according to PEMDAS, it says division first and then add and subtract. But you have to envision that there would be parentheses around the bottom of our fraction, because when you do division, you divide by a single number. So that means we have to combine the 9 and the 3 together into a single number, then do our division. So the 4 stays the same. 3 plus 9 is 12. Now we can do the division. We can either leave this as a fraction of 4 over 12. We can reduce it because we can divide by 4 in both the numerator or the denominator. Or we can go to the calculator and look at the decimal that it would give us, or maybe depending on which calculator you have, which version of the calculator you have, it'll tell you 1/3. Any one of these ways, especially if this is a multiple choice question, you can figure out the choices and which one matches your work. But this is rational again. This time it's because we have a repeating decimal. Remember, rationals repeat, rationals repeat. And there's no square root. All right, so let's do one on the calculator. We have 4 times 3 squared plus 2. Now, depending on which calculator you have, if you have a TI Inspire, when you turn it on, you can hit the home button and get to the menu, and you can just hit the letter A for calculate. It'll get you to this scratch pad screen. You could also hit the calculator button over here on the left, and it would get you back and forth between the graph and the scratch pad or calculator screen. So it's a couple different ways. And then we can just type in the question. The question, remember what it was, 4 times 3 squared plus 2. So 4 times 3 squared. Now we have to move the cursor out of the exponent position, and then plus 2. All that at once, boom, 38. Calculator does the work for us. A problem like this on a test would probably be multiple choice, so you wouldn't have to worry about showing work. So we can just use the calculator to get our answer of 38. And this is rational, because our number ends. We will get into irrational numbers more, and that's what we're going to do on Friday. So if you need some more practice, okay, we can look at some of these other examples. Now notice this time we have variables involved, letters, but I set it up so we know what numbers to use in place of those letters. So we're just practicing a little bit of substitution here. All right, so we're basically just going to substitute in the value for the letter. So this is 2 times 7 times 2 gets substituted in for the A, minus 6 that gets substituted in for the B, and then we can do our PEMDAS. So you can go to the calculator, type that in, get to the answer. I'm going to follow PEMDAS, which means inside my parentheses, I'm going to multiply first. And then inside the parentheses, I'm going to subtract. And then multiply. And this is rational, because the number ends. All right, let's jump to number 6. That way we can get through this lesson without ruining or taking up your whole day. First thing I want to do is substitute. Every B turns into the number 6. Every A turns into the number 2. So I'm going to substitute and rewrite it. A big square root sign over everything. The first B turns into a 6. Then I have parentheses. The second B turns into a 6. A number next to a letter means to multiply. So it's 3 times 6. Divided by, parentheses, the A turns into a 2. Now I did my substitution of multiplication 2 different ways here. 3 times 6 I used a multiplication dot, and then 2 times 2 I used parentheses. You can do it either way. They both mean multiplication. PEMDAS says do the inside most parentheses first. So this 6 stays where it is. And I have 3 times 6 here. Then inside this parentheses, 2 times 2 is 4. Now this is where you want to go to the calculator and just type it all in at once. It's going to be easier, it's going to be faster, save you time, and we'll get to the right answer as long as we plug it in correctly. So we can still go through doing the PEMDAS, but I think it's worth taking the time to make sure we type it into the parentheses and into the calculator correctly. So I'm going to jump over to my calculator. I'm still on the calculation screen, and I have to hit second, or the control button, and then the x squared button in order to get to a big radical. Now notice I'm going to type that stuff on the inside. So I start with a 6, I have parentheses here, and then I have 3 times 6, and it is divided by parentheses 2 times 2 minus 1. And the calculator takes care of closing the parentheses for me. So now I can just hit enter, and it says 6. And notice the calculator rewrites everything in fraction form, so I can see a different version of how this could be written. But it's still the same question. And since our answer came out to be 6, a nice generic regular old 6, that means it's rational. All right. Next, absolute value. We can do absolute value on the calculator. Absolute value is basically how far is a number away from 0, disregarding whether it's positive or negative. So the easy thing is you just take any number that you see that's inside the absolute value bars. It has to be simplified down to a single number first. Once it's a single number inside the absolute value bars, you just drop the negative. So this turns into positive 327. This turns into positive 3.46. Nothing else changes, you just drop the negative. But if there's some calculation work to be done, that has to be done first. So 4 minus 1 is 3 for my numerator. Negative 8 plus 18, either on the calculator or recognizing that this is basically the same thing as saying 18 minus 8, that would be 10. Now, a positive number inside the absolute value bars just comes out as a positive number, doesn't change. So my answer for that is 3/10. If we have a value out front of the absolute value, it gets treated as multiplication after we figure out what happens inside the absolute value. So here, following PEMDAS, 4 times 2 is 8. So I have negative 5 plus 8. Negative 5 plus 8 is positive 3. Then the negative 3 on the outside times the positive 3 that comes from the inside makes it negative 9. So that's absolute value. Now we can do absolute value on the calculator. Depending on which version you have, if you have the Inspire, you can use the letters A, B, S, and the calculator recognizes it as absolute value. And put parentheses and whatever you want to try. If we do negative 327, like the first example, boom, turns it positive. If we wanted to do the calculation we just finished, the negative 3 was on the outside, then A, B, S for absolute value. And then inside, we had negative 5 plus 4 times 2. So I can just type in negative 5 plus 4 times 2. Negative 9, just like we had negative 9. All right, so that was fast. Next, just some interpreting, some words. Some of what we have to do this year will be interpreting word problems. So add, addition, plus signs, sum, more than, increased by, total, gain, things that are going or increasing by addition. So when we get into word problems, here's a reference for you to help remember what words to use for which operations. Subtraction, sometimes they will say just subtract, or use the phrase less than, difference, decreased by, minus, reduced by. All those are cues that you should use subtraction. Multiplication, product is probably the most common one. Product of times, doublet means times 2, twice means times 3, triplet means times, doublet means times 2, twice also means times 2, triplet means times 3. And then when we look at division, they usually say divide, divided equally, or quotient. What we're going to do is just translate these a few sentences, phrases into mathematical expressions. It's an expression because there's no equal sign. So 12 more than a number. What we're supposed to do is define the variable. Let n equal the number. Let n equal the number. And 12 more than a number. More than would be addition. And when you add two numbers, the order doesn't matter. So when we write our expression, we could write it either way, 12 plus n or n plus 12. The ones that make a difference would be the subtraction and the division ones. So if we do the quotient of a number and 9, quotient is division, keep them in the order that they were listed. So let x equal the number, and we are doing the quotient of a number divided by 9. We could write that in fraction form of a number divided by 9. 4 times a number decreased by 7. 4 times a number cubed. So let's go let m equal the number 4 times the number cubed decreased by 7. All right, 15 less than the square of a number. Less than is subtraction. So after we define our variable, r is going to be our variable, or the number. 15 less than a number. Think about it in money terms. If you have $15 less than me, you take my account, or however much I have, and subtract the 15. So if we are 15 less than the square of a number, then we have to subtract the 15 afterwards. That's the only tricky thing about subtraction. All right, next. Get a different blue. No. 3 more than 5 times the number of dogs. So we're going to use D for dogs. 3 more than, so we're going to add 5 times the number of dogs. There's 5 times the number of dogs, and there's 3 more than that, plus 3. And our last one for this group, the product of 5 and y added to 3. The product of 5, the and part here separates the things that are being multiplied. We are multiplying 5 and y added to 3. So y is already the letter that's given. And we are adding that to 3. We are finding the product of that whole piece in 5. So it's 5 times y plus 3. All right, guys, we are almost done. Last thing for the day is undefined fractions. Okay? Simply put, a fraction is undefined when the denominator, which is the bottom, is 0. You cannot have 0 in the bottom of a fraction. You cannot divide by 0. So when they ask you the question, what value of x makes the fraction undefined, you focus on the denominator, because whatever the bottom is, it cannot be 0. Then you pretend it's an equation, which we'll get to more on Monday and next week, how to solve these, but you may remember. You would subtract 2 from both sides. So you're going to pretend it's like a normal equation, only it's a not equal to instead of an equal to. And then you would divide by 3. Divide by 3. Divide by 3. So you would say x cannot be equal to negative 2/3. Because if you plugged in negative 2/3 in for x into the original denominator, the denominator turns into a 0, cannot divide by 0. So that's how we do each one of these. We take the denominator, in this case negative h plus 5, and say it cannot be 0. and then solve like a normal equation. So I would subtract 5 from both sides. Because negative h cannot equal negative 5. And you would divide by negative 1, making the h positive. And then the answer to the question is that h cannot equal negative divided by negative turns it into positive 5. So what value of h makes the following expression undefined? The value of 5. Last question for our day 1 notes. Take the denominator. We're going to spend more time solving these equations next week. So it's okay if you're unfamiliar or uncomfortable with how to solve this equation, because you will be fine. It's just going to take us some time to go through some practices. So the first thing I would do is subtract the 18. Some of you may be fine with it because you've done it enough. Either way, it'll either be an easy day next week where you're just practicing what you already know, or an easy day because you're learning skills that aren't super difficult. But either way, we'll get through it together. So that is all for today, folks. Congratulations, finished day 1 in just over a half hour instead of 2 hours if we were in the regular school building. So enjoy, take care, and I'll talk to you soon.